So this is my CBA 2 review video with a few examples on it for you. We did one of these in class, but in case you were absent, I'm going to go ahead and kind of walk you through number 2. We're going to be simplifying using the exponent rules. Actually, let me minimize this or maximize this window for right now. So I've got cube root of x squared times y times z squared to the third power times 2x to the 0 power. Now anything to the 0 power is 1, so all that cancels out to 1. And then for this part, I'm going to go ahead and expand it out. So I've got cube root, and I've got x squared y z squared to the third power. So I'm going to write this 3 times. And then you can write times 1 at the end if you want to, but you don't need it anymore because times 1 doesn't change anything. And then I'm going to combine everything I've got. So keep your cube root. I've got x squared, and then x squared, and then x squared, which means I've got 2, 4, 6 x's being multiplied together, so that's x to the 6th power. And then I've got 1, 2, 3 y's being multiplied together, so that's y to the 3rd power. And that's a 6, and it doesn't really look like 1. Okay, that's better. And then I've got 2, 4, 6 z's being multiplied together, so z to the 6th power. Now, if you look at your answer choices at this point, you'll notice this doesn't really look like any of them. So that means we're not finished. Now, on one of the anchor charts in the room, we do have the equivalent rule for writing a radical with an exponent. So a cube root is a 1/3 power. So I'm going to rewrite this with a 1/3 power, and then I can kind of distribute the power in. So I'm going to use power rule to multiply 1/3 times each of these exponents. And if you prefer, you can think of it as dividing by 3. It really means the same thing anyway. So x to the 6th power to the 1/3 power is the same as x squared. Y cubed to the 1/3 power. Well, these cancel each other out to 1, so it's just y to the 1 power, or y to the 1st power. And then z to the 6th to the 1/3 is, again, z squared. And there's my simplified expression, so that one comes out as a. So if you were out yesterday, on Thursday, on Monday, oh my gosh, I'm way off. I'm off by 4 days. If you were gone on Monday, we did number 3 together. So I'll do it here for you. And this is very hard to read. That's 4x to the 3/2 power minus 100 equals 400. So this is a reverse PEMDAS problem. Solving is always reverse PEMDAS. So I'm going to start by adding or subtracting anything outside parentheses, and I don't have parentheses anyway. So I'm going to add 100 to both sides to cancel that out. So 4x to the 3/2 power equals 500. Now here's where a lot of people mess up. They really want to do the exponent next, but you can't. There's no parentheses here. So it's not 4x to the 3/2 power. It's 4 and then times x to the 3/2 power. So this has to come first. So I'm going to divide both sides by 4. So x to the 3/2 equals 125. And then we get to the exponent step. So to cancel the exponent, remember to use the reciprocal. Cross out, those cancel. And then x equals, and put this in your calculator, and please, please, please make that an exponent. Use the exponent key. That is not multiplication, it is an exponent. Please. Don't make it all the way through the problem and then mess up that step. Anyway, once you do 125 to the 2/3 power in your calculator, you get 25. So solve the system of 3 linear equations in 3 variables shown below using an appropriate method. So whenever you see this, you should think matrix. Whee! Matrix. And what do you need for a matrix? Well, you need your variables in order. It must be x, y, z, and then equals whatever happens to be. So let's put these in the right order. So I have 5z equals 2y. I want my variables on the left. So I have no x's. So remember that that's going to be a 0x. Then minus 2y. So when I pull it over to the left side, I subtract it from both sides. And then 5z is already on the correct side, so I'm just going to leave it there, 5z. And then equals 0, because there's nothing left on the right. So that's done. Second one, I have this negative x over here. I want it on the left. So I'm going to put x and then 4y. That one's okay. That one's on the correct side. Notice there's no z's in this equation, but I can't just forget it. So I need a 0z. Oz. And then it equals 2. So it's done. And the third one is, well, almost in the right order. So I got 3x plus 2y, and then minus 5z equals 12. And then you set up your matrix, either if you want to do reduced row echelon form in your calculator. Just make sure you don't forget your zeros and your negatives and such. So you could do it that way. Or you could do it, if you prefer, the other way. It's really up to you. Either way, you're going to get the same answer. You'll get the same solution. So it's fine whichever way you prefer. I just want to look at 10, just a couple things on 10. Where it says no more than, remember that's less than or equal to, and at least is greater than or equal to. That gets confused a lot. I know it says least there, but if you think about what that means when we talk that way, if I need at least 30 items, then it's okay to have more than 30, and it's okay to have exactly 30, but I can't have less than 30. So at least is really greater than or equal to. And no more than, again, I know it has the word more in it, but if you think about what that means when we talk that way, if I want to spend no more than $30, it's okay to spend exactly 30, and it's okay to spend less than 30, just not more than 30. So once you get those straight, I think you guys will be okay with the rest of this. Okay, let's flip to, we did 16. Most of the classes did 16. One did 17. So let's go to 18. You know what? It's a similar type of question. So 18. A polynomial function of degree 4 is shown below. Let me actually zoom in a little bit. Why are you crooked? Okay, cool. Okay, number 18. Which of the following represents the complete linear factorization of the function? So remember, when you see the word factorization, there's a couple things you want to think of. You want to think of a reverse box method where we have all the stuff inside. You want to think of roots or x-intercepts. And remember, if you can find the x-intercept, then you can, in most cases, just flip the sign and that'll give you the factor. So let's try this one. I'm going to go put this into Desmos. I'm going to sketch my picture on here so we can talk about it, looking at the problem at the same time. We're going to look at the x-intercepts. So let's go to Desmos. So I'm going to type in x to the 4th plus 2x to the 3rd minus 3x squared minus 8x minus 4. And there is my function. I'm going to look at my x-intercept. So I got negative 2. I got negative 1. I got 2. So my roots are negative 2, negative 1, and positive 2. So let me just sketch this on my paper real quick before I switch back. I've sketched this on my paper. Kind of. It's close enough. And I've got my roots. I've got x equals negative 2. I've got x equals negative 1. And I've got x equals positive 2. So those are my roots. So remember that if I have my root and I need to find my factor, I just have to flip the sign. Unless it's a fraction, and then you got to do a little bit more. We'll do one of those. So the root is -2. So my factor is x plus 2. So I know one of the factors of this polynomial is x plus 2. So I'm going to look at my answer choices and see, can I eliminate anything? And I can eliminate g because there's no x plus 2 there at all. And then I know I've also got x plus 1. And notice that this is on this is on a kind of what we would call a vertex if this were quadratic. So it doesn't pass through like these other roots do, just touches it and goes back. So that means that this factor is actually squared. It's there twice. And then this factor, if the root is +2, the factor would be x minus 2. So I'm going to look for those two things. I'm going to look for x plus 1 squared. I'm going to look for x minus 2. So there's x minus 2, x plus 1, but not squared. So that's not it. X plus 2, x minus 2, x plus 1 squared. Ooh, that could be it. And then check out this one. It has a factor of x minus 1, which would mean that I have a root of x plus 1, and I clearly don't because there's no root here at x equals 1. Excuse me, x equals 1. So that can't be the factorization because we don't have that factor. So that's not it either. So it is, in fact, H. So 16 through 22, even 23, honestly, are like this. So in fact, let's go to 23 next. 23 looks a little strange, and there's not one on the CBA that's exactly like this, but it's about roots and factors, so let's just do it. So it says a radical expression is shown below. Now this is square root, so remember that square root means I have some number, or some quantity, in this case a polynomial, times itself. So I'm really looking for the factors of this thing. It's just stated differently, but I'm still looking for the factors because I'm looking for these right here because I got 4x squared plus 9, and then your -12x is right here. When you combine those like terms, that's where you get -12x. So we're looking for the factors really. So I'm going to go ahead and graph 4x squared minus 12x plus 9. And this is just one way to do this problem. It's actually a perfect square, but we can do it. We can do it this way, reinforce the process. So 4x squared minus 12x plus 9. So notice the vertex hits exactly on the x-axis. That's why it's a perfect square, because no matter what my factor is, I'm going to have it squared. So my root is at 1.5, which I'm going to write as a fraction. So I'm going to write it as 3/2. Let me go back. So again, it was at 1.5, but I want to write that root as a fraction, so it's at 3/2. And remember, when you're looking at your root and your root as a fraction, to get the factor, you have to think reverse PEMDAS. So really, this would have been 2 times x. And this would have been, you would have subtracted 3 from both sides. So 2x minus 3 is your factor. And since we're talking about the square root, then we really don't need to write squared. It's just 2x minus 3. So it's D. 24, I think you guys will be okay. It's a matrix one. Just remember, these are already in order. Just don't forget your negatives. And remember, matrix B should be vertical. It should not be horizontal, because those won't multiply. So it must be one of the vertical ones. And these are like 3 and 4. So if you feel like you need help with these in class, please just let me know. But I think you guys are pretty good at that stuff. And that's it for these examples. So if you feel like you want something else, let me know, please. Ask me anytime. I prefer you ask me than not ask me. and I'll see you in class.